students. First of all, I welcome you all to the series of YouTube lessons organized by Department of Pre-University Education, Karnataka Government in association with Dakshina Kannada PU College Principals Association. In earlier videos, I covered 4 chapters like coordination compounds, surface chemistry, amines and biomolecules. Now it is my 5th chapter in the series of video lessons organized by Department of PU Education. Yes, it is electrochemistry, of course. And as far as the chapter electrochemistry is concerned, very important discussion as far as your annual examination and competitive exams are concerned. With respect to your annual examination, weightage of this chapter in the annual examination question paper is, yes, it is 8 marks. As many as 8 marks questions you can expect from this particular chapter in second PUC annual examination, right? Out of 8 marks, and that is there will be one question in part A of the SAT's question paper. There will be one question in part A of the question paper, that is question number 3, that carries 1 mark. So this is the 1 mark question from electrochemistry, that is question number 3 is from electrochemistry. Okay, now that carries 1 mark. The second question will be in part B of the question paper, that is question number 12. The question number 12 of the question paper is from electrochemistry and that carries 2 marks. This is the question number 12 is from electrochemistry, of course. And of course in the section 4 of the part D, in section 4 of the part D, there will be one question, that is question number, yes, it is 29, that carries 5 marks. So totally there will be 8 marks that you can expect from this particular chapter electrochemistry in second PUC annual examination, right? As far as electrochemistry is concerned, right? Electrochemistry deals with the study of interconversion of electrical energy and chemical energy. Electrochemistry deals with the study of interconversion of electrical energy and chemical energy, and also the behavior of electrolytes. So that branch of chemistry is called electrochemistry. As I said, there is a interconversion of electrical energy and yes, it is chemical energy. A branch of chemistry that deals with the study of interconversion of electrical energy and chemical energy, right? And of course, as far as electrical energy is concerned, it will be in the form of, yes, it is electricity. The electrical energy will be in the form of electricity. The total charge that is passed through the electrolyte, that is what we call it as electrical energy, that is electricity. Chemical energy will be in the form of redox reactions. Chemical energy will be in the form of, yes, it is redox reactions. Redox reactions, they are oxidation and reduction reactions. Oxidation reaction refers to the reaction where there is a loss of electrons takes place. Reduction is a reaction where there is a gain of electrons takes place, right? That is what we call it as redox reactions. That is electrochemistry deals with the study of interconversion of electrical energy and chemical energy. As you know, according to first law of thermodynamics, one form of energy can be transformed into another form. So also here in electrochemistry, we bring about interconversion of electrical energy and chemical energy. That means I can make use of this electrical energy. I can make use of this electrical energy, or I can say electricity, in order to perform redox reactions. I can make use of this electricity in order to perform redox reactions. That is, at the same time, I can convert chemical energy into electrical energy. Means I can make use of these redox reactions in order to generate electricity. What's the meaning of that interconversion of electrical energy and chemical energy? Electrical energy and electricity anteli. Now electricity na ಬಳಸ್ಕೊಂಡ್ಬಿಟ್ಟು I can perform redox reactions. ಹೌದಾ? ಹಾಗೇನೆ conversion of chemical energy to electrical energy andre I can make use of these redox reactions in order to generate electricity. That's the meaning of interconversion of electrical energy and chemical energy. That's why I said the branch of chemistry that deals with the study of interconversion of electrical energy and chemical energy. Interconversion, chemical energy can be converted into electrical energy. Electrical energy can be converted to chemical energy. That is interconversion of electrical energy and chemical energy. At the same time, this particular electrochemistry also deals with the study of behavior of electrolytes. This particular electrochemistry deals with the study of behavior of electrolytes. Electrolytes are the substances which conduct electricity either in solution or in molten state. We call them as electrolytes. That is, the substances which conduct electricity in solution or in molten state. Means when electricity is passed through the solution of electrolyte, that is, they conduct electricity. That means they allow electricity to pass through them, because these electrolytes are characterized by free ions. These electrolytes are characterized by free ions in their solution or in molten state. What is the meaning of molten state? That is melted form of the electrolyte. When solid electrolyte is melted, that is what we call it as molten electrolyte. Molten electrolyte is also characterized by free ions. The presence of free ions in molten electrolyte or in solution of electrolyte is main cause for the conduction of electricity through the electrolytes. So that is what we call it as electrochemistry, the branch of chemistry that deals with the study of interconversion of electrical energy and chemical energy, and also the study of behavior of electrolytes, and that particular branch of chemistry is called electrochemistry there. And of course, this, as far as electrochemistry is concerned, it has got its own importance in our day-to-day life also. Every branch of chemistry has got its own importance in our day-to-day life. Like that, this branch of chemistry has got its own importance in our day-to-day life. Let me list out some important aspects where we make use of electrochemistry, the concepts of electrochemistry, principles of electrochemistry, right? I can make use of this electrochemistry in order to bring about extraction of, some useful metals. I can make use of electrochemistry, or I can say I can make use of principles of electrochemistry in order to bring about extraction of some useful metals like sodium, potassium, magnesium and aluminium. Yes, it is. I can make use of principles of electrochemistry in order to bring about extraction of sodium, potassium, magnesium, aluminium, etc. These are the quite useful metals, and these metals can be extracted from their natural sources by making use of principles of electrochemistry. That is one importance that I can note down as far as electrochemistry is concerned. In addition to this, I can make use of these principles of electrochemistry in order to prepare some useful compounds like, some industrially important compounds like sodium hydroxide, chlorine, yes, some industrially important compounds like sodium hydroxide, chlorine and fluorine. They can be, it is manufactured by making use of principles of electrochemistry. That is another importance of this particular, it is electrochemistry. Apart from that, we depend on, it is petroleum products as a source of energy, right? They are the major sources of energy as far as our day-to-day life is concerned. But nowadays, they are very good sources of energy, no doubt. But they cause air pollution. That the continuous use of petroleum products as a source of energy lead to what? Air pollution. And that is because of that, nowadays, we are talking about alternate sources of energy. Like that, the concept, the principles of electrochemistry can be used in order to create, new technologies, in order to create new technologies which will be eco-friendly in generating energy there. Or I can say, I can make use of, batteries. I can make use of batteries, or I can say fuel cells. I can make use of, batteries and fuel cells as alternate sources of energy, and of course they are eco-friendly. They do not cause air pollution. And of course you might have heard about, nowadays even some vehicles like cars and bikes, they can be run by making use of some batteries, some lithium batteries. At the same time, we can run these mobiles and all those things, by making use of some batteries. Like that, that is batteries and fuel cells. They are the alternate sources of energy, and at the same time they are eco-friendly. They do not cause air pollution. That's why what I said, that principles of electrochemistry can be used in order to create eco-friendly technologies. I can make use of principles of electrochemistry in order to create eco-friendly technologies. And that is what we call it as the one more importance of the electrochemistry. And at the same time, even in biological systems also, this electrochemistry is playing very, very important role. That communication systems among the cells in our body is because of, yes, it is some electrochemical reactions. The communication system among the different types of cells in our body is mainly because of, yes, it is some electrochemical reactions. At the same time, that transmission of, yes, it is sensory signals from brain to the cells and vice versa is also because of electrochemical reactions. That is transmission of sensory signals from brain to the cell, or you can say from cells to the brain, is mainly because of, yes, it is certain electrochemical reactions that are going on in our body. That is also one more importance of, yes, it is electrochemistry there. And of course, one example I tell you there, that is as far as electrochemistry is concerned, I can make use of, yes, it is hydrogen, yes, it is oxygen fuel cell. That is at the same time, I'll tell you one important, yes, it is use of this electrochemistry there, that is hydrogen and yes, it is oxygen fuel cell is used in Apollo space program in order to generate electrical power. In order to generate electrical power, that is hydrogen oxygen fuel cells were used. Yes, it is. That is what we call it as one more important aspect as far as electrochemistry is concerned. At the same time, as far as biological importance is concerned, right? In heart, there is one point, that is what we call it as pacemaker. That pacemaker is responsible for generation of, yes, it is some impulses. That pacemaker is responsible for generation of some impulses which will be responsible for the heartbeat. The heartbeat is mainly because of the impulses generated by, that is what we call it as pacemaker, a point in heart. And that is also, yes, it is the generation of impulses by the pacemaker, which is responsible for the heartbeat, is because of electrochemical reactions. And that is what we call it as the importance of electrochemistry in our day-to-day life. At the same time, as far as the electrochemistry is concerned, I can make use of the principles of electrochemistry in order to prevent corrosion of various metals. I can make use of principles of electrochemistry. That means, we have some methods like, yes, it is galvanization, cathodic protection, electroplating. These are the some methods that I can make use of in order to prevent corrosion of metals. And these methods are based on principles of electrochemistry. And because of that, it is very essential for us to understand the principles of electrochemistry. Now at this moment, we'll go to the, yes, it is the first discussion under electrochemistry. It will be electrochemical cells. As far as electrochemical cells are concerned, these are the devices which will be used to bring about interconversion of electrical energy and chemical energy. Electrochemical cells are the devices which will be used to bring about interconversion of, yes, it is chemical energy and electrical energy. That is the devices used to bring about interconversion of chemical energy and electrical energy. That is what we call them as electrochemical cells. And these electrochemical cells are of two types. These electrochemical cells are two types. One, it will be, yes, it is galvanic cells. Electrochemical cells will be of two types. One, it will be galvanic cells, and second, it will be, yes, it is electrolytic cells. Second, it will be electrolytic cells. These are the two types of devices, electrochemical cells, that I can make use of in order to bring about, yes, it is interconversion of chemical energy and electrical energy there. As far as galvanic cells are concerned, these are the devices, these are the electrochemical cells where chemical energy is converted into electrical energy there. Galvanic cells are the devices, galvanic cells are electrochemical cells where there is a conversion of chemical energy into electrical energy. Whereas electrolytic cells are concerned, they are the devices, they are the electrochemical cells where electrical energy is converted into chemical energy there. ಸ್ವಲ್ಪ ಡಿಫರೆನ್ಸ್ ಅನ್ನ ಗಮನಿಸಿ. ಗ್ಯಾಲೋನಿಕ್ ಸೆಲ್ಸ್ ಅಲ್ಲಿ ಕೆಮಿಕಲ್ ಎನರ್ಜಿಯನ್ನ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿಯಾಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಬಹುದು. ಎಲೆಕ್ಟ್ರೋಲೈಟಿಕ್ ಸೆಲ್ಸ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿಯನ್ನ ಕೆಮಿಕಲ್ ಎನರ್ಜಿಯಾಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಬಹುದು. Just observe, as far as chemical energy is concerned, what I said, chemical energy will be in the form of, yes, it is redox reactions. We have two types of redox reactions: spontaneous redox reactions and non-spontaneous redox reactions. That is, spontaneous redox reactions are the redox reactions which proceed on their own without the assistance of external agents. That is what we call them as spontaneous redox reactions. Here in galvanic cells, I can make use of spontaneous redox reactions in order to generate electricity. I can make use of spontaneous redox reactions in order to generate electricity. That is what we call it as galvanic cells. And as far as electrolytic cells are concerned, in the case of electrolytic cells, I can make use of electricity. Here in electrolytic cells, I can make use of electricity in order to perform non-spontaneous redox reactions. Nodi, ಸ್ವಲ್ಪ ವ್ಯತ್ಯಾಸ ಗಮನಿಸಿ. ಗ್ಯಾಲೋನಿಕ್ ಸೆಲ್ಸ್ ಅಲ್ಲಿ ಸ್ಪಾಂಟೇನಿಯಸ್ redox reactions ಅನ್ನು ಬಳಸಿಕೊಂಡು ಎಲೆಕ್ಟ್ರಿಸಿಟಿಯನ್ನು ಜನರೇಟ್ ಮಾಡ್ತೀವಿ. ಎಲೆಕ್ಟ್ರೋಲೈಟಿಕ್ ಸೆಲ್ಸ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಸಿಟಿಯನ್ನು ಬಳಸಿಕೊಂಡು ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ redox reactions ಅನ್ನು ಪರ್ಫಾರ್ಮ್ ಮಾಡ್ತೀವಿ. ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ redox reactions are the redox reactions which take place only in presence of external forces. That means these are the redox reactions which take place only when electricity is passed through them. As long as electricity is passed through them, chemical reaction is going on. Otherwise, chemical reaction will be stopped. That is, I can make use of electricity in order to bring about, yes, it is non-spontaneous redox reactions. That is what we call it as electrolytic cells. And of course, the process is called, yes, it is electrolysis. We call it as, that process is called electrolysis. That's particular process where we make use of electricity in order to perform non-spontaneous redox reactions. That is what we call it as electrolytic cells. In the case of galvanic cells, I can make use of spontaneous redox reactions in order to generate electricity. Like that, galvanic cells are used to generate electricity, whereas electrolytic cells, where electricity is consumed in order to perform, as it is non-spontaneous redox reactions. And because of that, that is in the case of, yes, it is galvanic cells, delta G naught is negative. For the process that are going on in galvanic cells, delta G naught is negative because spontaneous redox reactions will be used to generate electricity. For spontaneous processes, delta G naught is negative. That is, delta G naught is negative for the processes that are going on in galvanic cells. Whereas in the case of electrolytic cells, delta G naught will be, yes, it is positive for the processes that are going on in electrolytic cells. That is, this is standard free energy change. This is standard free energy change. That is positive for the reactions that are going on in electrolytic cells, negative for the reactions that are going on in galvanic cells. So this is what we call it as the differences between galvanic cells and, yes, it is electrolytic cells. So this is something about introduction about, yes, it is electrochemical cells. Introduction about electrochemical cells. As far as the chapter electrochemistry is concerned, our interest is only on, yes, it is one of the galvanic cells, that is what we call it as Daniel cell. Our interest is on one of the, yes, it is galvanic cells, that is what we call it as Daniel cell. Let me talk about, yes, it is galvanic cells first. Yes, it is. Let me talk about, first of all, yes, it is galvanic cells. As far as galvanic cells are concerned, as I said, I can make use of these galvanic cells in order to generate electricity. ಈ galvanic cells ಅನ್ನು ಬಳಸಿಕೊಂಡು ನಾವು ಎಲೆಕ್ಟ್ರಿಸಿಟಿಯನ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಬಹುದು. ಹೌದಾ? And these galvanic cells are constructed. These galvanic cells are constructed by connecting two different electrode systems. ಈಗ ಎಲೆಕ್ಟ್ರೋಡ್ ಸಿಸ್ಟಮ್ ಅಂದ್ರೆ ಏನಂತ ಹೇಳ್ತೀನಿ. ಯಾಕಂದ್ರೆ ಫಸ್ಟ್ ನಿಮಗೆ ಎಲೆಕ್ಟ್ರೋಡ್ ಸಿಸ್ಟಮ್ ಬಗ್ಗೆ ಒಂದು ಐಡಿಯಾ ಬಂದ್ರೆ ಆ ನಂತರ ನಿಮಗೆ ಗ್ಯಾಲೋನಿಕ್ ಸೆಲ್ಸ್ ಅನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಕ್ಕೆ ಈಸಿ ಆಗುತ್ತೆ. And as far as electrode system is concerned, that is, as far as electrode system is concerned, or you can call it as electrode. Yes. In galvanic cells, electrode system refers to the system where metal or element is placed in a solution containing its own ions. Just imagine a beaker made out of glass or plastic. Yes, it is. It's a vessel made out of glass or plastic. It contains solution with ions like M, N plus ions. These are the ions present in the solution. If a metal or element is placed in a solution containing its own ions, this is what we call it as metal. Yes. When metal is placed in a solution containing its own ions, that results in what we call it as electrode system. System where metal is placed in a solution containing its own ions. That means we are going to establish a contact between metal and, yes, it is the ions there. There is a contact between, yes, it is metal and ion. And this particular electrode system is represented by M bar, M plus N. This is what we call it as a representation of, yes, it is electrode system. This is a metal, is in contact with metal ion in solution, and this particular single vertical line that represents interface between solution and metal. Now the metal is a solid, solution is a liquid. Interface between solid and liquid will be represented by a single vertical line, that is what we call it as electrode system. Say for example, if copper is placed in a solution containing its own ions, you are going to get copper electrode system. When zinc is placed in a solution containing its own ions, then you are going to get zinc electrode system. When, yes, it is chlorine is placed in a solution containing its own ions, then you are going to get chlorine electrode. When hydrogen is placed in a solution containing H plus ions, that is H plus is a ion of hydrogen, that is you are going to get hydrogen electrode. When oxygen is placed in a solution containing its own ion, OH minus ions, that results in, yes, it is oxygen electrode system. That is, electrode system corresponds to the system where element is brought in contact with its own ions. Electrode system is a system where the element is brought in contact with its own ions. That is what we call it as electrode system. What I said, galvanic cells can be constructed. Galvanic cells can be constructed by connecting any of the two electrode systems. Any of the two electrode systems. When two different electrode systems are connected, externally by electric wire, internally by salt bridge. I'll explain that later. Okay, now that is when two electrode systems are connected externally by electric wire, internally by salt bridge, then you are going to get one system, what we call it as galvanic cell. Now remember, when two different electrode systems are connected and there is a spontaneous flow of electrons from one electrode system to the another electrode system, that results in conversion of chemical energy into electrical energy. So that is what we call it as galvanic cells. And as far as your NCERT textbook is concerned, you are supposed to study one of the galvanic cells, that is what we call it as Daniell cell. Construction, working of, yes, it is Daniell cell. Now let us see the detailed aspect of, yes, it is one of the electrode systems at one of the galvanic cells. It will be, yes, it is Daniell cell. Daniell cell is an example for galvanic cell, because many electrode systems are available. When any of the two electrode systems are connected, then you are going to get, yes, it is galvanic cells. Therefore, you can construct many galvanic cells. You can construct many number of galvanic cells. Among the galvanic cells available, it will be a Daniell cell. And as far as Daniell cell is concerned, this Daniell cell is constructed by connecting, yes, it is copper electrode and zinc electrodes. Yes, when copper electrode, yes, is connected to, yes, it is zinc electrode. When copper electrode is connected to zinc electrode, yes, externally by electric wire, internally by salt bridge, and that results in the formation of Daniell cell. And as far as copper electrode is concerned, copper electrode is a system where, yes, it is copper metal placed in, yes, it is copper sulfate solution. When copper metal is placed in copper sulfate solution, that is aqueous solution of, yes, it is copper sulfate. When copper metal is placed in copper sulfate solution, you are going to get copper electrode. Like that, when zinc metal is placed in, yes, it is zinc sulfate solution, you are going to get, yes, it is zinc electrode. Look at this. This copper sulfate contains copper ions. When copper is placed in copper sulfate solution, there is a contact between copper atoms and copper ions, and that results in copper electrode. when zinc metal is placed in zinc sulfate solution, there is a contact between zinc atoms and Zn plus 2 ions. That results in zinc electrode there. Look here. Here it is a schematic diagram of, yes, it is a Daniell cell. Look at this. This is what we call it as one electrode where zinc metal is placed in. When zinc metal plate is placed in zinc sulfate solution. This is one more electrode system where copper metal plate is placed in copper sulfate solution. Yes. Here there is a contact between zinc atoms and zinc atoms are present in zinc plate. Zinc ions are present in, yes, it is zinc sulfate. There is a contact between zinc atoms and zinc ions here in the zinc electrode. Here there is a contact between copper atoms. Here there is a contact between copper atoms present in copper metal with, yes, it is copper ions present in copper sulfate. So this is zinc electrode and copper electrode. When these two electrodes are connected externally by electric wire, any conducting wire you can go for, externally by electric wire, internally by salt bridge. That results in one of the galvanic cells known as Daniell cell. That results in one of the galvanic cells known as Daniell cell. So this is what we call it as Daniell cell. And observe here, two electrode systems are connected through galvanometer. I can make use of this galvanometer for the detection of, yes, it is production of electricity. Production of electricity can be detected by making use of, yes, it is galvanometer here. So this is galvanometer. I'll give the details of this salt bridge later. Okay, now this is what we call it as, yes, it is Daniell cell. When zinc electrode system is connected to, yes, it is copper electrode system, and you're going to get Daniell cell. Once these connections are made, there is a spontaneous flow of electrons from, yes, it is zinc electrode to the, yes, it is copper electrode system. ಈ ಎರಡು electrode systems ಅನ್ನ external ಆಗಿ ಒಂದು electric wire ಮೂಲಕ, internal ಆಗಿ salt bridge ಮೂಲಕ connect ಮಾಡಿದ ತಕ್ಷಣ there is a spontaneous flow of electrons from zinc electrode to the copper electrode takes place. So once the flow of electrons starts in the external circuit, that means once the flow of electrons starts in the external circuit, that means there is a conversion of chemical energy to electrical energy. There is a conversion of chemical energy to electrical energy anta artha. So this is what we call it as Daniell cell. Just observe here. What I said, there is a spontaneous flow of electrons from zinc electrode to the copper electrode. Because when these electrode systems are connected, what happens, yes, it is at zinc electrode, oxidation of zinc atoms. At zinc electrodes, what happens, oxidation of zinc atoms into, yes, it is zinc ions takes place. Yes, it is with the loss of 2 electrons. ಈ ರೀತಿ zinc electrode system ಅನ್ನು copper electrode system ಗೆ connect ಮಾಡಿದ ತಕ್ಷಣ oxidation of zinc metal into zinc ions takes place at zinc electrode. And remember what I said, this is oxidation. This is oxidation reaction that is taking place at zinc electrode of the Daniell cell. And remember, in electrochemistry, as far as electrode systems are concerned, electrode system where oxidation takes place is called anode. And that's why in Daniell cell, zinc electrode is acting like a, yes, it is anode. Yes, Daniell cell alli zinc electrode alli oxidation ಆಗಿರೋದ್ರಿಂದ, that, yes, it is zinc electrode is called anode. That's why I have written anode here. Yes, and of course these electrons, which are passing through the, yes, it is external circuit, will be accumulated over the surface of copper metal. ಇಲ್ಲಿಂದ ಬಂದಂತ electrons ಏನಾಗ್ತವೆ ಅಂದ್ರೆ copper metal ಮೇಲೆ ಬಂದು accumulate ಆಗ್ತವೆ. And observe, here we have copper sulfate solution that contains copper ions. These copper ions are going to take up electrons present on the surface of copper. Thereby, copper ions will be deposited on the surface of copper metal. That means at copper electrode, what happens, these copper ions in the solution of copper sulfate, they take up electrons from the surface of copper and thereby they get reduced to, yes, it is copper metal. Look at this. This is a copper electrode where reduction of copper ions to copper metal takes place. And that is, this is what we call it as reduction reaction. And what I said, in electrochemistry, the electrode where oxidation takes place is anode. Similarly, this is a copper electrode where there is a reduction of copper ions to copper metal takes place. Because of that, copper electrode in Daniell cell is cathode. Yes, it is. Copper electrode in Daniell cell is cathode there. As far as Daniell cell is concerned, there are two half cell reactions. These reactions are half cell reactions, athava electrode reactions. This is one half cell, this is another half cell of Daniell cell. Zinc electrode is a one half cell, copper electrode is another half cell. At zinc electrode, at this particular half cell, oxidation of zinc takes place and therefore it is anode. At this particular half cell, reduction of copper ions takes place. That's why it is cathode. Yes. And just observe, as far as zinc electrode is concerned, this is negative electrode. That is the electrode where oxidation takes place. There is a negative electrode as far as Daniell cell is concerned. Or you can say, in any galvanic cells for that matter, very Daniell cell antalla, in any galvanic cells, the electrode where oxidation takes place is anode and it is negatively charged. Because, just observe, in the case of zinc electrode, there is the oxidation of zinc to Zn plus 2 ions. Enagutte zinc atoms, zinc plate in the oxidized to Zn plus 2 ions. Zn plus 2 ions will enter into the acidic solution. Zinc metal plate in the zinc atoms, oxidation agbiಟ್ಟು Zn plus 2 ions ಆಗಿ convert ಆಗುತ್ತೆ. Ions will enter into the solution, whereas these electrons will remain on the surface of acids. These electrons will remain on the surface of metal. Electrons do not enter into the solution. Ions will enter into the solution. ಇಲ್ಲಿ ಇರ್ತಕ್ಕಂತ zinc atoms Zn plus 2 ions ಆಗಿ solution ಗೆ enter ಆಗುತ್ತೆ. ಇಲ್ಲಿ electrons ಬರುತ್ತಲ್ಲ, these electrons will remain on the surface of metal surface. That means metal surface is characterized by electrons. Therefore, it is anode is negatively charged. Look at this. These electrons will be moving towards acids cathode. They are accumulated on the surface of acids copper metal surface. And these electrons over the copper sulfate, these electrons over the copper metal surface will be taken up by copper ions. ಇಲ್ಲಿರ್ತಕ್ಕಂಥ electrons ಅನ್ನ ಈ copper ions solution ಇರ್ತಕ್ಕಂಥ copper ions, they are going to take up the electrons from the surface of copper. Thereby copper ions will be deposited over the surface of copper metal. And thereby copper metal surface will be deficient with electrons, and that's why it is, yes, it is a positive electrode. Yes, that is as far as cathode of the galvanic cells is concerned, that will be positively charged. Anode of the galvanic cells will be, yes, it is negatively charged. That's why what I suggest you is, just remember one particular abbreviation, that is lone anta ಒಂದು mnemonics ನೆನಪಿಟ್ಕೊಳ್ಳಿ. Lone means L for left hand side electrode where oxidation takes place and it is anode and carrying negative charge. Yes, ಹೌದಲ್ವಾ? ನೀವು ಲೋನ್ ಅಂತ ವರ್ಡ್ ಅನ್ನ ನಿಮೋನಿಕ್ಸ್ ಅನ್ನು ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ಇದು ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಾಗುತ್ತೆ. L ಅಂದ್ರೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಎಲೆಕ್ಟ್ರೋಡ್, ಜಿಂಕ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಇಸ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಎಲೆಕ್ಟ್ರೋಡ್, ಕಾಪರ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಇಸ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಎಲೆಕ್ಟ್ರೋಡ್. ಹೌದಾ? ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಎಲೆಕ್ಟ್ರೋಡ್ where oxidation takes place and it is acting like an anode carrying negative charge. If it is a left hand side electrode, it will be right hand side electrode. If it is anode, it will be a cathode. If there is oxidation here, there will be reduction here. If it is negatively charged, it will be positively charged. Like that, yes, it is. You remember lone, that word lone, and thereby you can remember this particular aspect easily. So this is what we call it as, yes, it is Galvanic cells. What I said, these two reactions are half cell reactions, athava electrode reactions. And of course, these two electrodes are, yes, it is Redox couples antanu karibodu. Cathode and anode of the galvanic cells can be called as Redox couples anta karibodu. If I add these two electrode reactions, ee eradu electrode reactions ana add madidre, look at this, you can cancel the common terms here. Two electrons will be cancelled. Yes, and you left with what we call it as Zn solid, and of course copper ions, yes, in aqueous solution. Copper ions in aqueous solution. Okay na? Illi reactant side alli Zn ide, copper plus 2 ide, idu ಆಯ್ತು. In a product side alli ಇದೆ ನೋಡಿ, yes, it is, we have Zn plus 2, that is in aqueous solutions, and copper will be in solid form. This is what we call it as overall cell reaction. We call it as, this is overall cell reaction. ಇದನ್ನ overall cell reaction ಅಂತ ಕರೀತೀವಿ. ಇವೆರಡು ಕೂಡ half cell reactions ಅಥವಾ electrode reactions. Oxidation is electrode reaction that is going on in at anode. Reduction is a electrode reaction that is going on at cathode. Yes, always in galvanic cells, reduction takes place at cathode, and of course oxidation takes place at anode. Not only in galvanic cells, in all types of electrochemical cells, electrolytic cell ಆಗಿರಬಹುದು ಅಥವಾ galvanic cell ಆಗಿರಬಹುದು, the electrode where oxidation takes place is called anode, electrode where reduction takes place is called cathode. Don't differentiate electrodes on the basis of charges. To differentiate electrodes on the basis of, yes, it is reactions. ಯಾಕೆ ಇದನ್ನ ಹೇಳ್ತಿದ್ದೀನಿ ಅಂದ್ರೆ, galvanic cells ಅಲ್ಲಿ anode carries negative charge, ಅದೇ electrolytic cells ಅಲ್ಲಿ anode carries positive charge. Galvanic cells ಅಲ್ಲಿ cathode carries positive charge, whereas electrolytic cells ಅಲ್ಲಿ cathode carries negative charge. But in galvanic cells as well as, yes, it is electrolytic cells, oxidation takes place at anode, reduction takes place at cathode. ಹಾಗಾಗಿ ನಾನು anode ಮತ್ತು cathode ಅನ್ನ I just remember anode and cathode based on the reaction. The reaction, if the electrode where oxidation takes place is called anode, the electrode where reduction takes place is called cathode. So this is what we call it as, yes, it is Daniell cell. This is what we call it as Daniell cell. I said, no doubt it is Daniell cell. Okay, now, if yes, it is. If I use 1 molar solution of zinc sulfate in this particular Daniell cell, if I use 1 molar zinc sulfate solution and 1 molar copper sulfate solution at 298 kelvins, then the Daniell cell becomes standard Daniell cell agate. Again, Daniell cell becomes standard Daniell cell. That is standard Daniell cell. Yes, this is standard Daniell cell. Yes, this is what we call it as standard Daniell cell. If you are asked to write the cell reaction in the standard Daniell cell, you must write like this. This is Zn. Yes, and of course this is Cu2 plus 1 molar anta ಬರೀಬೇಕಾಗುತ್ತೆ. Standard Daniell cell ಅಂತ ತಕ್ಷಣ the concentration of copper ions in the Daniell cell is 1 molar, and that leads to, yes, it is Zn2 plus there. The concentration of Zn plus 2 ions will be 1 molar, and of course this is copper that is solid. Hige, this is what we call it as standard Daniell cell. When standard zinc electrode is connected to standard copper electrode, that the potential, that is, as far as the galvanometer is concerned, this galvanometer is used to, yes, it is measure, yes, it is potential difference between these two electrode systems. And of course, the potential difference between these two electrode systems is found to be 1.10 volts. The potential difference between these two electrode systems is found to be 1.10 volt if you maintain, yes, it is, yes, it is standard conditions. The potential difference between two electrode systems in standard Daniell cell, it will be 1.10 volts. Okay, that is as far as the Daniell cell is concerned, right? No doubt, I said there is a spontaneous flow of electrons from zinc electrode to the copper electrode. ಹೌದಾ? ಈ ಎರಡು zinc electrode system ಮತ್ತು copper electrode system ಅನ್ನು ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ, externally by electric wire, internally by solid bridge ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ, there is a spontaneous flow of electrons from zinc to the copper electrode ಅಂತ ಹೇಳಿದೆ. General question rise ಆಗುತ್ತೆ, why there is a flow of electrons from zinc to copper only? Why not in the opposite direction ಅಂತ ಪ್ರಶ್ನೆ ಬರುತ್ತೆ. And I said, because at zinc electrode oxidation takes place, zinc metal atoms undergo oxidation to liberate electrons. These electrons will be moving towards cathode, and of course there, the electrons on the surface of copper will be taken up by copper ions. And because of the oxidation reactions at, yes, it is zinc electrode, and there is a spontaneous flow of electrons from zinc electrode to the copper electrode. ಮುಂದಿನ ಪ್ರಶ್ನೆ, why there is oxidation at zinc electrode? ಹೌದಾ? ಮತ್ತೊಂದು ಪ್ರಶ್ನೆ ಏನು ಬರುತ್ತೆ ಅಂದ್ರೆ, why oxidation takes place at zinc electrode when zinc electrode is connected to copper electrode ಅಂತ ಪ್ರಶ್ನೆ ಬರುತ್ತೆ. And the reason is, and of course, as far as electrode systems are concerned, electrode systems have got their own tendency of losing or gaining electrons when a metal is placed in a solution containing its own ions. ಒಂದು electrode system ಗೆ ಇರತಕ್ಕಂಥದ್ದು ಪ್ರಾಪರ್ಟಿ ಏನಪ್ಪಾ ಅಂದ್ರೆ, when a metal is placed in a solution containing its own ions, and that electrode system has got its own tendency of either losing electrons or gaining electrons. And as far as zinc electrode is concerned, out of zinc electrode and copper electrode, zinc electrode has got more tendency of losing electrons compared to copper electrode. Because of that, oxidation takes place at, yes, it is zinc electrode, and there is a flow of electrons from zinc to copper there. ಅಥವಾ ಹೀಗೆ ಹೇಳ್ಬೋದು, out of zinc electrode and copper electrode has got more tendency of gaining electron compared to zinc electrode. And of course, that will be expressed in terms of electrode potential there. that I am going to discuss in the later discussion. Okay na? Adana ನಾವು in terms of electrode potential study ಮಾಡ್ತೀವಿ. And of course at this moment between zinc electrode and copper electrode, and of course in the case of standard Daniell cell, the potential difference between standard zinc electrode and standard copper electrode in standard Daniell cell is found to be, yes, it is 1.10 volt as measured by galvanometer connected in the external circuit. And remember, now at this moment, I am going to study effect of external opposite potential on the Daniell cell. ಈ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ಬಿಟ್ಟು ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ ಈಗ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ ಎಫೆಕ್ಟ್ ಆಫ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಅಪೋಸಿಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಆನ್ ದಿ ಎಸ್ Daniell cell as per your NCERT ಟೆಕ್ಸ್ಟ್ ಬುಕ್. ಅದಕ್ಕಿಂತ ಮುಂಚೆ ಒಂದು ಪಾಯಿಂಟ್ ಹೇಳ್ತೀನಿ ನಿಮಗೆ. Daniell cell ಬಗ್ಗೆ ನಿಮಗೆ ಪ್ರಶ್ನೆ ಏನು ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ಬೋದಂದ್ರೆ, write the half cell reactions that are taking place at anode and cathode of Daniell cell. This is a half cell reaction at anode, this is a half cell reaction at cathode, this is overall cell reaction. ಇದನ್ನ cell reaction ಅಂತ ಕರೀತಾರೆ. ಇದು overall cell reaction. When two electrode reactions are add ಮಾಡ್ಬೇಕಾದ್ರೆ common terms in the opposite directions will be cancelled. Electrons ಇಲ್ಲಿ reactant side ಇದೆ, electrons ಇಲ್ಲಿ product side ಇದೆ, ಅವೆರಡು ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ತೀನಿ. ಇದು ರಿಯಾಕ್ಟೆಂಟ್, ಎರಡು ರಿಯಾಕ್ಟೆಂಟ್ ಸೈಡ್ ಬರ್ತಿದ್ದೀನಿ, ಇದು ಪ್ರಾಡಕ್ಟ್ ಸೈಡ್ ಬರ್ತಿದ್ದೀನಿ. ಇದು ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ as overall cell reaction in the Daniell cell. ಅದೇ ನಾನು ಸ್ಟ್ಯಾಂಡರ್ಡ್ Daniell cell ಅಂತ ಹೇಳಿದಾಗ you must mention the concentration of ions as 1 molar, temperature as 298 kelvins. Okay na? Istuna ಮನಸ್ಸಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ. Now at this moment we'll take up, yes, it is the next discussion, that is effect of external opposite potential on, yes, it is Daniell cell, right? And of course, standard Daniell cell, okay na? Effect of external opposite potential on standard, yes, it is Daniell cell. For that purpose, let me have some slight modification in the diagram. ಈ diagram ಅಲ್ಲಿ ಸ್ವಲ್ಪ modification ಮಾಡಿಬಿಟ್ಟು ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ. ಆಗುದಲ್ಲ? We'll see that. Yes. Just let me study the next discussion, that is effect of external opposite potential on Daniell cell ಅಂತ ಹೇಳಿ. ಸ್ವಲ್ಪ just ನೋಡಿ, in order to apply external, yes, it is opposite potential over the Daniell cell. Just here it is a arrangement. You just observe, external opposite potential is applied by using battery there. ಇಲ್ಲಿ ಒಂದು ಬ್ಯಾಟರಿ ಬಳಸ್ಕೊಂಡು ನಾನು external opposite potential ಅಪ್ಲೈ ಮಾಡಿದ್ದೀನಿ. ಸ್ವಲ್ಪ ಅರೇಂಜ್ಮೆಂಟ್ ಅನ್ನು ನೆನಪು ಮಾಡ್ಕೊಳ್ಳಿ. This is a resistance. ಇದೆಲ್ಲ ನೋಡಿ ಬ್ಯಾಟರಿ ಇದೆ. Yes, it is. Let me say that if external opposite potential is less than 1.10 volts ಅಂತ ತಗೊಂಡ್ರೆ, yes, if external opposite potential is 1.10 volts ಆದರೆ what is the effect of external opposite potential on the Daniell cell ನೋಡೋಣ. ಓಕೆನಾ? As I said, in the case of Daniell cell, there is a flow of electrons from, yes, it is zinc electrode to the copper electrode. Electrons of zinc electrode in the copper electrode ಗೆ flow ಆಗುತ್ತೆ. By convention, electric current will be flowing from copper to zinc. ಹೌದಾ? That is, the direction of flow of current will be opposite to the direction of flow of electrons. Electrons zinc electrode ಇಂದ, yes, it is copper electrode ಹೋಗ್ತಾ ಇದ್ರೆ ಕರೆಂಟ್ ಯಾವತ್ತೂ ಕೂಡ ಅದರ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಇರ್ತದೆ. That is, electrons flow from zinc electrode to the copper electrode, current will be in the opposite direction. ಅದು ನಿಮಗೆ ಗೊತ್ತಿದೆ, ಹೌದಾ? ಇಲ್ಲಿ ನೋಡಿ, if the external opposite potential is less than 1.10 volts, ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತಕ್ಕಂತ ಎಕ್ಸ್ಟರ್ನಲ್ ಅಪೋಸಿಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇಲ್ಲಿ ಸ್ಟ್ಯಾಂಡರ್ಡ್ Daniell cell ಇರತಕ್ಕಂತ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಗೆ ಕಡಿಮೆ ಇದ್ರೆ, if external opposite potential is less than the standard cell potential of, yes, it is Daniell cell, then, yes, it is electrons, they are flowing from, electrons flow from, yes, it is zinc to copper electrode. No change in the direction of flow of electrons. Electron flow ಅಲ್ಲಿ, direction of electron flow ಅಲ್ಲಿ ಯಾವುದೇ ಬದಲಾವಣೆ ಇಲ್ಲ. Chemical reactions will be similar to that in the case of Daniell cell. Same reaction takes place, that is zinc undergoes oxidation, copper ions undergo reduction, and that leads to, yes, it is Zn plus 2 and of course plus copper there. The same reaction. This is a reaction that is taking place when external opposite potential is less than 1.10 volts. there will be no change in the direction of flow of electrons, or you can say there will be no change in the direction of flow of current, and chemical reaction similar to that in the case of, yes, it is usual Daniell cell. Now what I will do here, I am going to increase, yes it is, I am going to increase, yes, I am going to increase the external opposite potential. ಸ್ವಲ್ಪ ಈ ಗ್ಯಾಪ್ ಅನ್ನು ಗಮನಿಸಿ, ಅವಾಗಲೇ ಈ ಗ್ಯಾಪ್ ಜಾಸ್ತಿ ಇತ್ತು, ಸ್ವಲ್ಪ ಕಡಿಮೆ ಆಯ್ತು, ಹೌದಲ್ವಾ? Now I am increasing the external opposite potential, okay na, opposite to the, yes it is Daniell cell. That is, now I am increasing external opposite potential applied over the Daniell cell. That is, if external, yes it is, opposite potential is equal to 1.10 volts ಆಗ್ಬಿಡ್ತು. ಈಗ ನಾನು ಮಾಡಿದೆ beginning less than 1.10 volts apply ಮಾಡಿದೆ. ಈಗ I am increasing the external opposite potential. Now external opposite potential is equal to, yes it is 1.10 volts. That is, ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ standard cell potential of Daniell cell is also 1.10, is opposed by external opposite potential whose value is also, yes it is 1.10. ಹೌದಾ? ಈಗ ಏನಾಗಿದೆ, ಈಗ external opposite potential is equal to 1.10, then no flow of electrons, then that is, there is no flow of electrons, there is no flow of electrons, and of course no chemical reaction takes place, no conversion of chemical energy to electrical energy, because that is the cell potential developed by, yes it is the Daniell cell is opposed by, yes it is external opposite potential which is equal in magnitude but opposite in direction. ಹೌದಾ? ಈ external opposite potential ಇದೆಯಲ್ಲ, the magnitude of external opposite potential is equal to the magnitude of the potential difference developed in the standard Daniell cell. Both are equal and opposite. That's why no flow of electrons in the external circuit, no conversion of chemical energy to electrical energy. ಹೌದಾ? So that is what we call it as no chemical reaction at all. ಹೌದಾ? Just imagine, now at this moment I am going to increase, yes it is the external opposite potential further. That means if external opposite potential is greater than 1.10 volts, beginning less than 1.10 volts maintain ಮಾಡಿದೆ, second case ಅಲ್ಲಿ equal to 1.10 volts maintain ಮಾಡಿದೆ. ಈಗ external opposite potential is greater than, yes it is standard cell potential. ಆಗ the chemical reaction is reversed. That is, this chemical reaction will be reversed. That is, copper is undergoing, yes it is oxidation, yes, copper undergoes oxidation and of course gets converted to copper plus ions. ಹೌದಾ? zinc ions will be undergoing reduction. ಈ chemical reaction ಇದೆಲ್ಲ ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ರಿವರ್ಸ್ ಮಾಡಿ, ಇಲ್ಲಿ Zn copper plus reactants ಆಗಿತ್ತು, ಬಟ್ ಇಲ್ಲಿ ಏನು ಪ್ರಾಡಕ್ಟ್ಸ್ ಆಗಿದೆ. ಇಲ್ಲಿ Zn plus copper atoms ಪ್ರಾಡಕ್ಟ್ ಆಗಿತ್ತು, ಇಲ್ಲಿ reactants ರಿವರ್ಸ್ ಆಗುತ್ತೆ. That means electron flows from, yes it is electrons flow from, yes it is electrons flow from, yes it is copper to, yes it is zinc, in the direction opposite to the direction of electrons in the case of Daniell cell. ಹೌದಾ? Daniell cell ಅಲ್ಲಿ electrons zinc ಇಂದ copper ಹೋಗ್ತಾ ಇತ್ತಲ್ವಾ, ಈಗ ಏನಾಗುತ್ತೆ, that is direction of electron flow will be reversed, and that is electron flows from copper to zinc, because when external opposite potential is greater than 1.10 volts, oxidation of copper takes place, reduction of zinc takes place. Because of that, electrons flow from copper to zinc. This is a chemical reaction, and because of that, that Daniell cell is converted into electrolytic cell. Now under this particular condition, Daniell cell will be converted into, yes it is electrolytic cell. ಒಂದು ಪ್ರಶ್ನೆ ಕೇಳಬಹುದು, under what conditions Daniell cell can be converted to electrolytic cell ಅಂತ ಹೇಳಿ. ಆಗ ನೀವು ಬರೀಬೇಕು, when external opposite potential is greater than 1.10 volts, then Daniell cell can be converted to, yes it is electrolytic cell ಅಂತ ಬರೀಬಹುದು. ಓಕೆನಾ? ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, not only Daniell cell, any galvanic cells for that matter, if external opposite potential is greater than standard cell potential, this is 1.10 ಇದೆಯಲ್ಲ, that is standard cell potential of Daniell cell. If external opposite potential is greater than standard cell potential of any galvanic cell, then yes it is that galvanic cell is converted into electrolytic cell anta baribeku. And of course, look here, electron flows from copper to zinc. So this is what we call it as, yes it is effect of external opposite potential on Daniell cell. ಆಗ್ಬೋದಲ್ಲ? Yes. ಇಲ್ಲಿ ಒಂದು Daniell cell ಅಲ್ಲಿ ಜನರಲ್ ಆಗಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ಗೆ ಕೆಲವು ಕ್ವಶನ್ಸ್ ಇರ್ತದೆ. ಓಕೆನಾ? ಆ ಪ್ರಶ್ನೆಗಳಿಗೆ ಕೆಲವು ಉತ್ತರಗಳನ್ನು ಹೇಳುವಂತ ಪ್ರಯತ್ನ ನಾನು ಮಾಡ್ತೀನಿ. ಓಕೆನಾ? ಈಗ ನೋಡಿ, ಒಂದು ಪ್ರಶ್ನೆ ಏನಪ್ಪಾ ಅಂದ್ರೆ, that is when zinc electrode is connected to copper electrode, ಏನಾಗುತ್ತೆ, oxidation takes place at, yes it is, oxidation takes place at zinc electrode, reduction takes place at, yes it is, copper electrode anta helde hauda. Reason helde nanu ಏನಪ್ಪ ಅಂದ್ರೆ, in the case of zinc electrode, the tendency of losing electrons by zinc electrode is more than the tendency of losing electron by copper electrode anta helde hauda. Because of that, oxidation takes place at zinc electrode, reduction takes place at copper electrode anta helde hauda. If same zinc electrode, yes, if same zinc electrode is connected to aluminum electrode anta itkoli, yes, if same zinc electrode is connected to aluminum electrode. Iga zinc electrode andre zinc metal atoms, zinc metal placed in, yes it is a solution containing Zn plus 2 ions hauda. Aluminum electrode andre aluminum placed in solution containing its own ions, Al3 plus ions. When zinc electrode is connected to aluminum electrode, what happens to know? That is, oxidation takes place at aluminum electrode, reduction takes place at zinc electrode. Andre, when zinc electrode is connected to aluminum electrode is acting like an anode and zinc electrode is acting like a cathode agate. Illi, when zinc electrode is connected to copper electrode, zinc is anode here, but here zinc is cathode when it is connected to aluminum electrode. Yakendre, out of zinc electrode and aluminum electrode, tendency of losing electrons by aluminum electrode is more than the tendency of losing electrons by zinc electrode. Hagagi, when zinc electrode is connected to aluminum electrode, zinc electrode acts as a cathode. When zinc electrode is connected to copper electrode, zinc acts as a anode. Again, ಇಲ್ಲಿ ನೋಡಿ, Daniel cell ಅಲ್ಲಿ copper is a, yes it is cathode. When same copper electrode is connected to silver electrode, when same copper electrode is connected to silver electrode, then copper is acting like a, yes it is anode, zinc electrode is acting like a cathode. Because in the case of copper and silver electrode, the tendency of, yes it is losing electrons by copper electrodes is more than the tendency of losing electrons by silver electrode. That is, copper electrode has got more tendency of losing electrons compared to silver electrode. That's why copper is anode here. But here, in the case of Daniel cell, tendency of losing electrons, that in the case of, yes it is zinc, is more than that of copper. That's why copper is here cathode, but here anode. Hagagi, whether an electrode acts as an anode or cathode in a given galvanic cell, that depends on the nature of the another electrode with which it is connected. That's why the tendency of losing or gaining electrons by the electrodes in a given galvanic cell is a relative tendency. It's not an absolute tendency, it's a relative tendency. That is one more important aspect that I wanted to clear. Apart from that, you might be curious to know the role of salt bits here. In my NCERT book, our details illa, but out of curiosity, I'll explain that. What is the role of salt bits? What exactly that salt bits here is anteli? Okay, now, as far as salt bit is concerned, it is a U-shaped glass tube. This is a U-shaped glass tube, yes, in which the hot solution of, yes it is KCl is mixed with agar powder. Hot solution of KCl is mixed with, yes it is agar powder. And this mixture is in a liquid state at higher temperature. ಅದಕ್ಕೆ hot solution ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಈ ಮಿಕ್ಸ್ಚರ್ liquid form ಅಲ್ಲಿ ಇರ್ತದೆ. The hot solution of KCl mixed with agar powder is filled in, yes it is U-shaped glass tube. ಈ solution ಅನ್ನ hot solution of KCl in agar powder, ಕಾರ್ಬೋಹೈಡ್ರೇಟ್ ಅದನ್ನ ಆ ಪೌಡರ್ ಅನ್ನ ಮಿಕ್ಸ್ ಮಾಡಿ, ಎರಡನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿ ಆ ಮಿಕ್ಸ್ಚರ್ ಅನ್ನ U-shaped glass tube ಅಲ್ಲಿ fill up ಮಾಡಬೇಕು. Now this the U-tube containing a mixture of KCl and agar powder is allowed to cool. It is allowed to attain room temperature. When it attains room temperature, the mixture attains, as it is, the mixture becomes semi-solid. Liquid state ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ mixture ಏನಾಗುತ್ತೆ, semi-solid ಆಗಿಬಿಡುತ್ತೆ. Now, at this moment, here in the, yes it is U-tube, we have K plus and Cl minus ions. ಈಗ ಈ U-tube ಅಲ್ಲಿ ಏನಿದೆ, K plus ions ಮತ್ತೆ Cl minus ions ಇದೆ. They are suspended in agar medium. They are suspended in agar medium ಅಲ್ಲಿ ಈ K plus ions ಮತ್ತೆ Cl minus ions suspend ಆಗಿದೆ. Now, it is placed inverted with each limb of the U-tube in each electrode. And remember, the openings of this particular U-tube will be closed by means of cotton. ಆ ಓಪನಿಂಗ್ಸ್ ಅನ್ನ ಕಾಟನ್ ಇಂದ ಕ್ಲೋಸ್ ಮಾಡಿಬಿಟ್ಟು and that U2 is placed inverted. Yes. Just imagine, as far as NaCl is concerned, before the chemical reaction takes place, that solution of zinc sulfate is electrically neutral, solution of copper sulfate is electrically neutral. That is in the case of zinc sulfate. Before that chemical reaction, that is total charge on the positive ions will be equal to total charge on the negative ions. Therefore, zinc sulfate solution is electrically neutral. Copper sulfate solution, total charge on the copper ions will be equal to the total charge on the sulfate ions. Solution is electrically neutral. Just imagine, once the reaction takes place, ಎರಡು electrodes connect ಮಾಡಿದಾಗ reaction start ಆಗುತ್ತೆ. Reaction start ಆದರೆ ಏನಾಗುತ್ತೆ? Zinc atoms will be, yes, it is dissolved in solution in the form of Zn+2 ions. ಇಲ್ಲಿರ್ತಕ್ಕಂಥ zinc plate ಇಂದ Zn+2 ions solution ಗೆ ಎಂಟರ್ ಆಗುತ್ತೆ. ಆಗೇನಾಗುತ್ತೆ? Positive charge on the solution increases. ಬರೀ zinc ions ಮಾತ್ರ ಬರುತ್ತೆ, sulfate ions ಬರಲ್ಲ. ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ? Solution attains positive charge. Just imagine, if this salt bridge is not there, the solution gets positive charge. This positively charged solution doesn't allow electrons to flow in the external circuit. ಹೌದಲ್ವಾ? ಈ solution ಗೆ ಏನಾದರೂ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬಂದ್ಬಿಟ್ರೆ ಇಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆಗೋದೇ ಇಲ್ಲ, ಬಿಕಾಸ್ ದಿಸ್ ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ ಸೊಲ್ಯೂಷನ್ ಅಟ್ರಾಕ್ಟ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ ಏನಾಯ್ತು? ರಿಯಾಕ್ಷನ್ ಸ್ಟಾರ್ಟ್ ಆಗಿ ಮೊದಲು ಕಾಪರ್ ಸಲ್ಫೇಟ್ ಸೊಲ್ಯೂಷನ್ ಎಲೆಕ್ಟ್ರಿಕಲಿ ನ್ಯೂಟ್ರಲ್ ಆಗಿತ್ತು. ಒನ್ಸ್ ದ ಕಾಪರ್ ಅಯಾನ್ಸ್ ಆರ್ ಡಿಪಾಸಿಟ್ ಓವರ್ ಕಾಪರ್ ಮೆಟಲ್, ಈ ಕಾಪರ್ ಅಯಾನ್ಸ್ ಕಾಪರ್ ಮೆಟಲ್ ಮೇಲೆ ಡೆಪಾಸಿಷನ್ ಸ್ಟಾರ್ಟ್ ಆದಾಗ ಏನಾಗುತ್ತೆ? ನಂಬರ್ ಆಫ್ ಪಾಸಿಟಿವ್ ಅಯಾನ್ಸ್ ಕಡಿಮೆ ಆಗುತ್ತೆ, ಅಂದ್ರೆ ಸೊಲ್ಯೂಷನ್ ಅಟೈನ್ಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್. ಈ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಕಾಪರ್ ಅಯಾನ್ಸ್ ಕಡಿಮೆ ಆದ್ರೆ ಏನಾಗುತ್ತೆ? ಸೊಲ್ಯೂಷನ್ ಗೆಟ್ಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್. ದಿಸ್ ನೆಗೆಟಿವ್ಲಿ ಚಾರ್ಜ್ ಸೊಲ್ಯೂಷನ್ ಡಸಂಟ್ ಅಲೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಟು ಎಂಟರ್ ಇನ್ ಟು ದ ಕಾಪರ್ ಮೆಟಲ್. ಹೌದಾ? ಈ ಸೊಲ್ಯೂಷನ್ ಗೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬಂದ್ಬಿಟ್ರೆ ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈ ಕಾಪರ್ ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಅಲ್ಲಿ ಎಂಟರ್ ಆಗೋದೇ ಇಲ್ಲ. ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ? ಇಫ್ ಸಾಲ್ಟ್ ಬ್ರಿಡ್ಜ್ ಇಸ್ ನಾಟ್ ಯೂಸ್ಡ್, that hinders flow of electrons in the external circuit. And because of that, it's very essential to maintain electrical neutrality of solutions at the electrodes. Because of that, I use salt bridge. ನೋಡಿ ಏನಾಗುತ್ತೆ? ಇಲ್ಲಿ zinc ions zinc sulfate solution ಗೆ ಎಂಟರ್ ಆದ ತಕ್ಷಣ ಎರಡು ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಎಂಟರ್ ಆಗಿದೆ ಅಂತ ಅರ್ಥ. ಹೌದಾ? And therefore, in order to neutralize that two extra positive charges, two Cl- ions from the salt bridge enter into the, yes, it is zinc sulfate solution. ಇಲ್ಲಿ ಒಂದು Zn+2 ion enter ಆದ ತಕ್ಷಣ salt bridge ಇಂದ 2 Cl- ions will enter into the zinc sulfate solution, so that solution becomes electrically neutral. This +2 charge of 1 Zn+2 is neutralized by -1 charge of 2 Cl- ions. ಹಾಗಾಗಿ solution gets neutrality. The solution will be maintained electrical neutrality. ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿಂದ ಕಾಪರ್ ಅಯಾನ್ಸ್ ಕಾಪರ್ ಮೆಟಲ್ ಮೇಲೆ ಡೆಪಾಸಿಟ್ ಆದ ತಕ್ಷಣ that will be balanced by entry of 2 K+ ions. ಎರಡು ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಲಾಸ್ ಆದ ತಕ್ಷಣ ಈಕ್ವಲೆಂಟ್ ಅಮೌಂಟ್ ಆಫ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ K+ ions will enter into the copper sulfate solution. ಒಂದು ಕಾಪರ್ ಅಯಾನ್ ಕಾಪರ್ ಮೆಟಲ್ ಮೇಲೆ ಡೆಪಾಸಿಟ್ ಆದ ತಕ್ಷಣ 2 K+ ions from salt bridge will enter into the solution. ಹೌದಲ್ವಾ? Yes, thereby the salt bridge is used to maintain electrical neutrality of two solutions in the, yes, it is galvanic cells. ಹೌದಾ? ಜಸ್ಟ್ ರಿಮೆಂಬರ್, ಯಾವ್ದು ಈ ಸಾಲ್ಟ್ ಬ್ರಿಡ್ಜ್ ಅಲ್ಲಿ ಬಳಸುವಂತದ್ದು KCl ಅನ್ನೇ ಯಾಕೆ ಬಳಸ್ತಾರೆ ಅಂದ್ರೆ, ಸಮಟೈಮ್ಸ್ ವಿ ಮೇಕ್ ಯೂಸ್ ಆಫ್ KNO3, ಓಕೆನಾ, NH4NO3, KCl. ಯಾಕೆ ಅಂತಂದ್ರೆ ದಟ್ ಈಸ್ ದ ಮೊಬಿಲಿಟಿ ಆಫ್ K+ ions will be almost similar to the mobility of Cl- ions. The speed with which K+ ions are moving will be similar to the speed with which Cl- ions are moving. ಯಾಕಂದ್ರೆ electrical neutrality should be maintained simultaneously in both the solutions. ಹಾಗಾಗಿ speed of K+ ions should be equal to speed of Cl- ions, and that is there. Mobility of K+ ions will be equal to mobility of Cl- ions. That's why KCl is used as electrolyte in, yes, it is salt bridge. That means salt bridge is used to maintain electrical neutrality of solutions at anode and cathode of the, yes, it is galvanic cells. So this is what we call it as role of salt bridge. Agboodalla? Yes. Now in the next video we'll see, that is some theoretical aspects, okay na, that is reasons behind, yes, it is conversion of chemical energy to electrical energy by making use of one concept, what we call it as electrode potential concept. Agboodalla? That we'll see in the next video. Thank you very much, right?